Hello, so today's video is going to be about the cosine rule. So we've looked at the sine rule, how to prove the sine rule, where the sine rule comes from, and we've looked at a couple of examples. So we looked at a basic example of the sine rule, and then we looked at the ambiguous case for the sine rule. So when you can actually get two different angles potentially when you use the sine rule. So today we're going to look at the cosine rule and how you prove that. So the cosine rule is probably something you've seen before. So if you've got a triangle, capital A for the angle there, the opposite side you'll call lowercase a, capital B an angle there, the opposite side you call lowercase b, capital C there your angle, opposite the angle you've got lowercase c. Then the formula is a squared is equal to b squared plus c squared. Take away 2 times b times c times cos of this angle A. Or alternatively, cos capital A of this angle is equal to b squared, so one of the lengths adjacent the angle, squared plus another this c there, so this length adjacent again to the angle A, and then square that. Take away the opposite side squared, divided by 2 times b times c. So that's how that works. So again, key thing is that your lowercase letters are the sides opposite your angles. And that's just the key thing to know, and that corresponds to these formulas as well. So like your A there, that's one of your sides. This capital A is going to be the angle opposite this lowercase a, so just like the diagram here. So we're going to prove that this rule is true, and this is how we prove it. So again, I'm going to copy out the triangle we got. So we've got angle A and then side A opposite it. We've got angle B, sorry, this should be capital B, so capital B there, and then we've got a side B opposite that B, and then capital C there, and then a side C opposite that capital C there. Okay, so then how are we going to prove this? So the idea is we're going to focus on this, firstly, this left-hand side right angle triangle. So I'm going to draw like a dashed line down there to split the triangle into 2 right angle triangles. So let's look at this triangle there. I'll call this triangle 1. So if we focus on triangle 1, then let's think about the base of this triangle 1. So we know that cosine is adjacent over hypotenuse. So using SOHCAHTOA, adjacent over hypotenuse. So the adjacent side to this this angle A would be this side on the bottom here. I'm just going to call that X. Let's just call that X there. So this base there we'll call X, and this is X divided by C. So that means that X is going to be equal to the C length, this C length there, times by cos A. Okay, so we have that. Now then, so this, if that's going to be X there, then this, because the entire base of this triangle is B, we're going to call that B because it's opposite the angle capital B there. Then this part of the triangle, this base over there, is going to be B take away X, because this part here is X. The entire length is B, so B take away X is going to give us BX there. So our base is going to be BX. So we can again use cosine, but again with this cosine C here. So cosine of C is going to be equal to the adjacent, which is again B minus X, divided by the hypotenuse, which is A. So again, we get that A times cosine of C is equal to B minus X. So we get that. Now, let's think about the height of this triangle here, like the height of this right angle triangle, both triangle number 1 and triangle number 2. Let's think about the height. So we can use Pythagoras to work out the height. So using Pythagoras with triangle number 1, sorry, I'll move this writing over here. I'll move that over. Let me try that again. I will move this over to here, and this will be triangle number 2. So I'll do this in blue. Triangle 2 down here. Okay, if we go back to triangle 1 then, so let's use Pythagoras to find the height of this triangle. So remember, a squared plus b squared equals the hypotenuse squared. So we've got x squared plus h squared is equal to this hypotenuse c squared. So that means then we know that x is c times cos a. So you've got c times cos a all squared plus h squared is equal to c squared. So that means that h squared is equal to c squared, take away c squared cos squared a, and that's because when you square this c cos a, you get c squared and a cos squared, because you want to square both these values here. So take that away from both sides, we get that. So we get that h squared equals this. Okay, so now let's do the same thing, but with triangle number 2. So this time, again, we've got, we're going to use Pythagoras with triangle number 2 here, and I'll do this in blue. So Pythagoras tells us that b minus x squared plus h squared is equal to the hypotenuse a squared. So we get that. Again, I'm just going to make the writing smaller again. Sorry, let me try that again. There we go, and we'll move it up like that. So we've got h squared. If we take away this b minus x all squared from both sides, we get a squared minus b minus x all squared. And so this is going to give us a squared, and then subtract in the brackets here. So b minus x times by b minus x, just repeating that. So we get a squared, take away b squared, and then we're going to get b times minus x, which is minus bx, and then minus x times by b, another minus bx. So we get minus 2bx, and then plus x squared there, so plus an x squared at the end. So we get that, and then therefore we've now got a formula for h there. So sorry, h squared. So h squared is equal to that, but h squared is also equal to this as well. So let's kind of put a box around this here. So we've got h squared equals this, and we've got h squared is equal to this. So both of these expressions must be equal. So therefore, c squared minus c squared cos squared a must be equal to this a squared, and then minus these things here, minus the b squared, so minus b squared, and then plus 2bx, because actually we want to add 2bx, so 2bx, and then subtract this x squared, because again we got this in the brackets, so subtract an x squared. Sorry, let me write this in ESA. So my plus 2bx, and then subtract x squared. Okay, so we've now got that that result there. I'll just move this across to there, and I'll just again try and keep everything on the same page by moving my writing up. Okay, so we have that. So we've got, yeah, c squared, take away c squared, cos squared a equals a minus b squared plus 2bx, and then minus x squared. So we know from up here that x is equal to this here, so c times cos a. So we can actually plug that in. So you get c squared, take away c squared, cos squared a is equal to, again, this a squared, take away b squared, plus 2b, and then x, which is equal to this c cos a. So remember, x equals c cos a. So I'm going to swap that with that x there. So we get c cos a, and then we've got a minus x squared at the end. So again, minus this value squared. C cos a times c cos a gives you c squared cos squared a. So minus c squared cos squared of a. Now, so we've got an equation here with cos c cos squared a on both sides. So negative c cos squared a, sorry, negative c squared cos a squared on both sides. We can add this to both sides, and this will actually cancel out. So we're going to be left with c squared equals a squared minus b squared plus 2bc cos of the angle A. Now what we can do is make a squared the subject to the formula. So we can take away, so we can add the b squared to both sides. So we get b squared plus c squared equals a squared plus 2bc cos a. And then finally, we can do the last step. We can take away the 2bc cos a from both sides. And if we do that, we will get the final result. So therefore, we get that a squared equals b squared plus c squared, and then minus this 2bc cos a. And that was our proof. So that proves that, yeah, the cosine rule, and this is called the, obviously, the cosine rule. So the cosine rule. Or the law of cosines, or the cosine law. Yeah, this is the cosine rule. And again, just as a as a reminder, you got a squared equals b squared plus c squared minus 2bc cos a. You can rearrange this to make cos a the subject to the formula. So what you can do is you can add the 2bc cos a to both sides, subtract the a squared. That would get you 2bc cos a is equal to b squared plus c squared minus a squared. Divide both sides by 2bc. You get cos a equals b squared plus c squared minus a squared divided by 2bc. And that's another way in which you can express it if you want to calculate an angle. So to use the cosine rule, the key thing is that you need 3 letters and an angle. So there are 2 cases when you can use the cosine rule, and we'll go through this in more detail in the next video. So you can use the cosine rule if the question gives you 2 sides of a triangle and an angle, and you've got to calculate a missing side. Or alternatively, if you get all 3 sides of a triangle and you want to find one of the angles, you can use the cosine rule. So yeah, that's just how you prove the cosine rule, but we'll do an example tomorrow.